In addition to the list, another very useful data structure is the association. We're going to look at associations now. We've seen that the command word counts returns an association as its output. I'm going to evaluate the plain text. I'm going to do word counts on the plain text of this article about Dolly the sheep, and I'm going to assign that to the symbol Dolly word counts, and I'm going to use a semicolon to suppress the output. If we use the head command, we can see that Dolly word counts is an association. An association is a data structure that has pairs of elements. If we look at the 10 largest items in Dolly word counts, I'm just going to evaluate this, we can see that the first pair is the points to 32. That tells us that the word the occurs 32 times in this article. The word to occurs 20 times, the word Dolly occurs 16 times, and so on. Now, in an association, the first member of each pair is called the key, and the second member of each pair is called the value. If it helps, you can think of the association kind of like a dictionary. If you have a word, you can look up its definition, or a telephone book, although I guess those no longer exist. In the olden days, if you wanted to know a person's phone number, you'd start with their name, and there would be a link to their phone number. In this next expression here, if we start with the key, we can ask for a value. So we use Dolly word counts, we put a pair of square brackets after it, and then we put the key that we're searching for. If we ask for Dolly, we find that it shows up 16 times. If we ask for the word announced, we find that it shows up 1 time. Now, overall, we can use the length command to see how many key value pairs there are in an association. So this shows us that there are 347 different key value pairs. And since this was generated by word counts command, we know that there are 347 different words that occur at least 1 time in this article. The keys command gives us a list of the keys that occur in an association. I'm going to do that, and then I'm going to use short to just see some of them. And we can see that the keys here, as we know, are the, to, Dolly, of, and so on. In this list, the keys have been ordered according to descending frequency, so the is the word that occurs the most times. Now, if we try to retrieve something from our association that doesn't exist, if we try to retrieve a key that doesn't exist, we'll get a key missing, or a key absent error, a kind of missing error. And we can use a special test, key member Q, to see if a particular key occurs in a particular association. So before we run something and get an error, we could actually test for it and see whether or not it exists at all. So for example, does the key Dolly exist in this association? Yes, it does. Does the word lamb exist in this association? It does not. Now, like the key command, there's a values command which gives us a list of values. And here we have the frequencies of the words in descending order. The word the occurs 32 times. That's what we're seeing here. We're only seeing the right-hand member of each pair in our association. If we were to use a plot, if we were to do a plot of those values in that previous list there, we see this particular curve. The word the occurs a lot of times, the word to occurs a lot of times, but most of the words in this article only occur 1 time. So this curve starts off very high, it falls fast, and then there's an inflection point, and then there's a lot of words that only occur 1 or 2 times. And this is a typical distribution of words in a text. We're going to see this again in a future lesson. Now, the word counts command treats the same word with different capitalization, or in different cases, as different words for the purposes of frequency. So if we search for the word the with a lowercase t, we get 32 counts. If we search for the with a capital T, we get 5 counts. For some applications, we want to count those as the same thing, and for some applications, we want to count them as different things. So it's important to be explicit about which we're doing here. If we wanted to count them as the same thing, then we would use the ignore case option, for our word counts command. And I'm just going to do that and show you that then if we do that, we should end up with, let me zoom back just a little bit here, we should end up with 32 plus 5, or 37 counts for the if we ignore case, and that is in fact what we get. Now, one of the things that we might want to do is determine whether certain classes of words occur in a particular list. And for this example, I've used a set of words that are called the modal verbs. Modal verbs express things like possibility, probability, obligation, and so on, and they also express orientation towards the future. Here I've made a list of modal verbs, and in the next command, I use a command that we learned about before, intersection, to say which of these modal verbs also appears in the keys of Dolly's word counts. And I evaluate that, and it shows me that of these, 3 of them could, will, and would appear in that article. Now, you may or may not be interested in modal verbs specifically, but any list of terms, whether they're search terms that you're interested in, or classes of terms like names of months or days of the week, or particular holidays or particular sporting teams or businesses, whatever, if you've got a list of items that you're interested in, you can use intersection with the words that appear in a particular text to see if those items appear in that text. Now, we haven't seen this yet, but it's also possible to get word counts to count the frequency of bigrams and trigrams. So we add a parameter to the word counts command. 2, in this case, is going to give us bigrams. And I'll just show you what this looks like. And then I'm going to ask for the 10 largest. Here we see that the 2-word pair, Dolly the, occurs 5 times. The sheep occurs 5 times. Of the occurs 4 times, and so on. So that's what bigrams are. They're these 2-word units. Now, they're particularly useful in cases like Ian Wilmot, a person's name, first name, last name, that occurs 3 times. And if we're looking for things like names of people or institutions or whatever, we're often searching for bigrams or trigrams. If we want to look up a value, we give it a list with the first element and the second element. Here I'm looking for the 2 words clone humans, and we see that that occurs 1 time in this article. In the next command, I've actually asked for trigrams, and I ask how many times does the expression Dr. Ian Wilmot occur in this list, and we find that that occurs 3 times. Now, it's sometimes also the case that we not only want to know if something occurs, but we want to find particular patterns. So if we look at the 10 largest bigrams and we ask for the keys, we find that they are Dolly the sheep, of the, and so on. We can use a command called cases to pull elements from a list that match a particular pattern. So for example, if we wanted to know every bigram that has Dolly as the first word, we would use this expression here. We're asking for the keys of the bigrams, and we're pulling out all the cases where Dolly is the first word and anything is the second word. And that gives us Dolly the, Dolly is, so on, Dolly Partons. If we do the other pattern, if we ask for words preceding Dolly, we can get all the bigrams like that. Of Dolly, 1997 Dolly, name Dolly, mammal Dolly, and so on. This single underscore in Mathematica is called blank. That's its name. This is just the shorthand for it. And it's a pattern that we use very often to refer to a single element. If we're curious about how blank works, we can use the shorthand for information, the question mark, and the shorthand for blank, the underscore. And if we evaluate that, it gives us information about that particular pattern.